Hello and welcome back. We are doing chapter 12 of D3 new syllabus mathematics for O-level 6th edition, and we are doing the difficult questions from the chapter. We have chosen the review questions, and from it in the previous video we did question number 9, and in this one we are going to be doing the very last question, question 10. Now this question has very limited information. We are given a larger circle with a radius of 15 centimeter and a center O. Now, placed on the perimeter of the larger circle are two smaller circles that are touching each other externally, and their radii are 5 centimeters. Now, the shaded region is a very small region, a gap between the larger circle and the two smaller circles. You are asked to find the perimeter and the area of the shaded region. So, let me first redraw this diagram. Here we are. I have drawn a line from the center of the circle O that crosses the center of the smaller circles, and then it touches the circumference of the larger circle. In red, I have denoted the radius of the smaller circle 5, and in blue I have marked a line 10 centimeter. You can see that it extends to the circumference and it becomes 15 as we are given in the question. Now I've drawn a green line from the center of the circle, larger circle O, to the line joining the centers of the two smaller circles. It is in green and you can see that it is 90 degrees to the horizontal line. I've also marked two angles in beige color and I have called them theta. We have to find the value of theta. We take the cosine of the angle theta and comes out to be 60 degrees. Remember that we are looking at this multicolored triangle with the hypotenuse blue, the perpendicular is red, and the base is green. So 5 over 10 and the theta comes out to be 60 degrees. For convenience, I have written theta only on the left side, not on the right side, because there are too many things written on the right side, the right circle. So don't get confused, both of these angles are the same. Now in pink, I have also marked another angle beta, and we are also going to find its value. Simply 90 minus 60, 30 degrees, because sum of angles in a triangle is 180. So, if theta is 60, this little angle here on the diagram, it is 120 degrees. Yes? Now, remember that we are to find the perimeter first, and if you observe carefully, this 120 degree is a sector of a circle. So we know how to find the perimeter of a sector. Also note that since we know the angle beta, we realize that angle beta is half of the original angle. So the angle subtended by the larger circle is twice into beta, that is 60 degrees. Now with that information, we can easily find the perimeter. The perimeter is basically the larger arc, this one here, plus the two smaller arcs, this one and this one, right? So the larger arc will have an angle of 60. The formula of the perimeter for a circle is 2 pi r, the radius is 15, and since we are looking at only a segment, so we are going to have 60 over 360. In the second part, the two small arcs are going to have a similar perimeter. Why? Because both of them subtend equal angles 120 degrees. So 120 divided by 360 into 2 pi r, the radius here is now 5, and we multiply it by 2 because both of them are the same. Now we can find an expression, and this comes out to be 11 whole 2 over 3 pi, and this is what we are given in the question in the book, that you have to show that this is the perimeter of the shaded region. Now let's move on to the area of the shaded region. Let me label 2 points on the larger circle x and y. This is where the radius hits the circumference of the larger circle while it passes through the center of the two smaller circles. Area of the sectors, we can find it very easily. Both of the sectors are identical. 120 divided by 360 into pi r square, where r is 5. Next we find the area of the large sector, and that is 60 over 360 into pi r square, where r this time now is 15. We'll label 2 more points. Centers of the smaller circles are labeled A and B. So now Consider the triangle OAB. Half into base into height. Now we know the base, this is 10, but the height, the green line, we don't know that. So it's very easy, we can use Pythagoras theorem. The height h has to be 5 multiplied by under root 3, and put that into the expression for the area of triangle OAB. We get the area as 25 multiplied by under root 3 centimeters square. Shaded area is found by subtracting the area of the two smaller sectors and the area of the triangle OAB from the area of the large sector. This is going to give us the area of the gap, which is the shaded region. This comes out to be 22.1 centimeters square, and this is our answer. Now this is it from the mensuration topic. On your right you can see the playlist, and in the playlist you can find numerous other questions from different chapters that we have done. Now if there are any questions, please do ask them in the comment section below. I'll be very happy to answer them. Thank you for watching and take care.